Hi, everyone. Let's. So it's time to start here. I'd like to start with questions from homeworks. Does anyone have questions from homeworks? At this point, we've assigned like 1 through, what do? We did 1 through 6. 1 through 10, I think, is what we did, right? That sounds right. Does anyone have questions? Charlie? 3, sure.
Ooh, that's a nice sharpener.
All right, so if I'm looking at number 3, the directions say use or find the exact values using sum and difference identities. So I'm going to start by looking at number 3 and noticing that the angle is in radians. I'm going to change that to degrees right away. I don't have to do it that way, but oftentimes it makes our life a little bit easier to do that. So I'm just going to multiply by pi over 180. So the pi's cancel on that. 12 goes into 180, let's think here. So 6 goes into both of those, and then 3 goes into both of those. That's not right. Oh, that's because that should be a 2. Okay. So that should be 15. Okay. And then 5 times 15 is 75. So this is tan of 75 degrees. So far, so good? So what I'm going to do is I'm going to look for 2 unit circle angles that either add up to 75 or I can subtract them to get 75. Probably 30 plus 45 would be the natural choice. That's usually pretty easy to see. Are there other answers? Of course there are. There's lots of them, but that's, I think, the most obvious choice. So then I go to my identity sheet and look for the sum and difference identity represented by tan of 30 plus 45. I see that should be SD number 5. So I can write that then as tan of 30 degrees plus tan of 45 degrees divided by 1 minus tan of 30 degrees times tan of 45 degrees. Does that feel okay? Once I've done that, I'm now going to go to my unit circle so that I can look up the values for tan 30 and tan 45. So if I look at my unit circle and 30 degrees, I remember that tan is y over x on the unit circle. So at 30 degrees, the y is 1/2, and the x is square root 3 over 2. And at 45 degrees, the y is square root 2 over 2, and the x is square root 2 over 2. So far, so good, Charlie? Okay. I'm going to simplify these now. So 1/2 divided by root 3 over 2 just becomes 1 over root 3. And root 2 over 2 divided by root 2 over 2 is just 1. And if I multiply the denominator, 1 times 1 over root 3 just becomes 1 over root 3. Now, I have an answer, but I don't love the form of this answer for two reasons. One reason is I have fractions inside of fractions. Don't love that. Second reason is I have radicals in the denominator. I don't love that. So I'm going to start by taking care of the fraction side of fraction part first. AJ? Sure. So to do that, what I'm going to do is I'm going to look at the denominator of the little fractions. They're both the same denominator. They're both square root 3. So I'm going to multiply the top and bottom of my fraction by that square root 3. And just kind of distribute that through. So 1 times 1 over square root 3 just becomes 1. And then 1 times root 3 is just root 3. So I have the same thing going on there. So now I've eliminated the fraction inside a fraction issue that I had. But I still have a radical in the denominator of my fraction, right? Now, this is kind of the worst case scenario for that because I have like a number plus or minus the radical. So to get rid of the radical in my denominator, I need to multiply by the conjugate. So I'm going to take the same thing as my denominator, just with the opposite sign inside, or in the middle. And the bummer here is now I have to FOIL this out. The good news is that the denominator is that difference of two squares multiplication pattern that you might remember from Algebra 2. So I know how to FOIL that out really quickly without having to do a lot of work. If you don't remember that pattern, you can always just FOIL it out regular. You don't have to use that shortcut, but I like to use it because, shoot, it just makes life a little bit quicker. Otherwise, we're going to just be FOILing. So I just FOILed out the numerator then. Is everybody okay there? I know that squares cancel square roots. And 1 squared is just 1. So the denominator just becomes 3 minus 1, or 2. And the numerator has a 1 plus 3, so that's a 4. And then I have 1 root 3 plus another root 3. How many total root 3s do I have then? 2 root 3s, right? I took 1 root 3 and added another root 3 to it. That gives me 2 total root 3s. So I write that as 2 root 3. And then when I look, I notice that the coefficients on both part of that fraction, everything is divisible by 2. So it turns out if I write this as 2 separate fractions with common denominators, I can reduce each of them separately. So 4 divided by 2 is just 2, and 2 root 3 divided by 2 is just root 3. And that guy's going to be my best and final answer. And worth pointing out to you guys that this is all checkable with your calculator, right? So we did, the original problem was tan of 5 pi over 12. If I put my calculator into radian mode, since that's a radian angle, I do tan of 5 pi divided by 12. I get this decimal. And then if I check my answer, 2 plus root 3, I get the same decimal. So I'm convinced that I have the correct answer here. That's checkable for all of these problems I've been asking you to do. You have to be a little bit careful about the mode your calculator's in, that you have it degree versus radian. Or you could have just leave your calculator in degree mode the whole time and just use tan 75, which we converted in the beginning, right? Could have done that too. You'd have to start with the original problem. Charlie, does that feel, that feels good? Okay. Other questions on this one before we move on? Okay. Other questions from homework then? Okie doke. Very good then. So today we want to talk about two other types of identities. We want to talk about the, let me double check. I forgot where we left off. Okay, we did power reducing. Okay, so we have to do half angle. And I think that should be good. All right. So again, if you don't have, or if you have your sheet still that I passed out last time, you should take that out because we're going to be referencing that throughout everything we're about to do. If you weren't here when I passed it out, there's extra copies of this guy on top of the file cabinet. Feel free to go and grab one, or if you've lost yours since then, again, there's extra copies on top of the file cabinet. You can go and grab one if you need one. Right up there. Yeah, no problem. So let's say we're asked to find the exact value using half angle identities for sine of 22.5. So notice that 22.5 is not a unit circle angle, but I recognize that 22.5 is half of a unit circle angle. Because if I multiply 22.5 by 2, I get 45. And that is a unit circle value. So this is a problem that can be done using my half angle identities. Does everybody feel okay with that? Okay. So I'm going to go to my, I don't know why I wrote tan there all of a sudden. What are you doing, Mr. Gulick? Still on the previous problem that had tangents in it or something. Sorry, I meant sine there, obviously. Woo! At this point, I'm going to go to look at my identity sheet. I'm going to find the half angle identities and find the one for sine. I notice in this case, my x in the formula is 45 degrees. So I'm just going to plug 45 degrees into the x in my formula. Does everybody feel okay with how I came up or found the correct identity and how I plugged the numbers in? Okay. Next, I'm going to go to my unit circle and find the value for cosine of 45 degrees. Can somebody look at their unit circle and tell me what cosine of 45 degrees is? Great, Nora. Square root 2 over 2 is correct. We found that by locating 45 degrees on our unit circle and then looking at the x coordinate, because cosine is the x coordinate on our unit circle. So now I have that same fraction inside a fraction business going on, right? Everybody see that? I got the little fraction inside of a big fraction. What was the trick we used to handle that? I'm going to multiply the top and bottom of my fraction by the denominator of the little fraction. But I need to do something else also. What is different about this identity than any of the previous identities we've looked at? That's going to matter for this step anyways. It's not the plus or minus, although that is true. That is different from all the other identities so far. I'm looking at the square root that's over the whole thing, right? Can I take a number not under a square root and multiply it to a number under a square root? No, we cannot. Everybody okay with that? So we can't do this, what we've just written down. But we can do that. Now I have a number under a square root that I'm multiplying inside of a square root, so it's going to be fine. Do you guys get what I'm saying? Like if I have 2 times square root 3, well, that's just 2 square root 3. We can't multiply those together. But if I square root 2 times square root 3, that's square root 6. Those I can multiply together, right? It's like I'm staring at a bunch of zombies. Do you guys see why I needed to put the square root over these things, or no? It's an important distinction. I want to make sure that when we're doing these things, we do things correctly, right? I want you to do well. I'm just trying to walk us through and explain why we need it there. All right. I'm going to accept your zombiness for now. Is everybody okay with what I did there and how I got that? We're good with the arithmetic that happened? Okay. Now I still have one little problem with this aside from the plus or minus, which we'll get to. What's the issue that's going on here? I'll give you a little hint. Remember in your Algebra 2 class, you would have talked about how the square root of a fraction is the same thing as square root of the top and the square root of the bottom. What does that mean that I have here? In this problem, means I have a square root in the denominator, right? Which we don't love. The nice part is I don't have to worry about doing anything complicated, because if I just rewrite this as the square root of the top and the square root of the bottom, what do you notice? Come on, it's sitting right there for you. Somebody notice it. Okay, but what could I do with it? The square root of 4 is 2, right? I don't have to rationalize the denominator or anything. I don't have to do anything funky there. I just have to simplify the radical, right? Isn't that nice? Took care of the radical in the denominator. Now I want to make a word of caution here. Notice as I'm writing this, I'm being really careful when I'm drawing my radical so that the radical goes over the entire fraction. When I mean it to go over the entire fraction, and I have it going just over the numerator when I mean for it to go just over the numerator. I am going to be picky about the way you write this on your sheet of paper. Okay? So if you mean the fraction or the whole fraction to be under the radical, you got to draw a radical big enough that it covers the whole fraction. If you mean the radical to go over just the numerator, you have to draw the radical so that it's over just the numerator, so that the fraction bar is like underneath the check mark part of the radical. Did you guys get what I'm saying? It just has to be clear to me when I'm reading it whether we're talking about whether that radical is over the denominator or not, because it matters, right? It means two different things. Is that okay? Okay. I want to warn you guys about what I'm going to be picky about before I be picky about it. You know what I'm saying? Just to be fair. Yes. I have one final thing that we need to take care of in this problem, and that's the plus or minus. So I should have only one of them. And now this is a pretty easy thing to take care of to decide whether this should be positive or negative, but we need to remember to do it. I go back to the very original problem. What quadrant is a 22.5 degree angle in? The first, second, third, or fourth quadrant? First is correct, because I know that the first quadrant goes from like 0 to 90 degrees, right? So 22.5 is in there. And I remember that all silly turtles crawl. So in the first quadrant, all of sine, cosine, tangent need to be positive. So this problem, the plus or minus, should be a plus. Yeah, positive. So I just go all the way through and just cross out my plus and minuses. Is it okay to do that right at the beginning of the problem to decide whether it should be positive or negative? Sure. You could do it right at the start. You could wait to the end. You could do it somewhere in the middle. But you have to do it at some point, right? And it's an easy thing to check. We're just going to use all silly turtles crawl. But you have to use the original angle measure, not the angle measure over 2. You can't use like the 45 degrees. In this case, it wouldn't have mattered, but it certainly could in other cases. Let's do another example of this, because there's a couple of new things that kind of go on here that we want to be careful about that we've done enough example of. Let's do this one. All right. So cotangent of negative 105 degrees. And again, we want to find the exact value using our half angle formulas. So my first step would be to write this as half of a unit circle angle, right? So negative 105 is half of negative 210. Everybody agree with that? I notice that negative 210 is a unit circle angle, right? If I add 360 to negative 210, that's 240. That's definitely a unit circle angle. So I'm happy with that. What is my problem, though? Look at your half angle identities. Which one should I be using? Oh no! There's not a cotangent one on my sheet. Well, it turns out that it's not a problem. So if I remember from chapter 5, cotangent is the reciprocal of tangent. Which one was that? That was R6. And now I can use my half angle 3. Now I have 3 choices here, right? If you look at your sheet for H3, I have 3 choices. I would choose, well, again, let me be clear. It doesn't matter which one you choose. Any of them are going to work. But I want to choose the one that's going to make the least work for me. Everybody agree with that? Would I ever pick the first one, the plus or minus square root? No. Never going to pick that one. That looks like the worst one to deal with. Could you do it? Yes. It'll be fine. I think it looks like the most work, though. I'm always going to be picking between the second 2. Everybody agree? So far, so good? Now, when doing these problems, the worst part about this is when I have like 1 plus square root in the denominator, right? And I have to do the foiling and all that mumbo jumbo. Like, that's a pain in the tuchus. I don't want to have to deal with that. So I would want between the other 2 versions of tangent, I want the version that ends up with just a single trig function in the denominator, not 1 minus sine or 1 minus cosine or 1 plus cosine. Now keep in mind, this one we're doing the reciprocal of tangent. So the one that I want is the last one. Will make, I think, our lives easiest. Because when I do the reciprocal now, I have that. I drew this fraction bar like a big fat fraction bar, so you could tell like what was from the previous problem and what is me using the identity, I hope. Is that clear? Does having the big fat fraction bar help? I don't know. Maybe it does, maybe it doesn't. That's what I'm going for. That's why I drew it so big and heavy. I shouldn't call it fat. Maybe it's sensitive. It's a sensitive fraction bar.
Large.
Yeah. We'll call it thick, right? It has less negative connotation. Okay. So now would be time to go to my unit circle to find the values of cosine of negative 210 and sine of negative 210. The problem is that negative 210 isn't an angle on my unit circle. So I'm going to add 360. To that gives me 150. I don't know if I said the wrong number before, didn't I? Did I say 210 or 240 or something? So that's just me adding 360. And now I'm going to go to my unit circle. So if I locate 150 degrees on my unit circle, cosine is the x coordinate. So that's negative root 3 over 2. And sine is the y-coordinate. That's 1/2. I have the fraction inside a fraction thing going on, so I'll just multiply by 2 over 2. Which gives me 2 minus root 3 over 1, or just 2 minus root 3. And again, if I want to check this, got to go put this back in degree mode. My original problem was cotangent of negative 105. I don't have a cotangent button on my calculator, so I have to write it as 1 over tangent negative 105. Then I check it with the answer I just got, 2 minus root 3. And those match up real nice. I'm pretty convinced that's what's going on. How do you guys feel? Is that okay? All right. That's all of what I want to do with Chapter 6. We're going to do one test with 6 and 7, given that Chapter 6 is really just these like 3 skills. But for today, what we'd like for you guys to do is to do numbers 23 through 26. And then worksheet 1. Next time we'll be starting chapter 7, and we'll have like a 6-7 test where they'll have, like, some questions from chapter 6 and some questions from chapter 7. Probably like a 1/3, 2/3 ratio of questions. 1/3 of them chapter 6 questions because there's not much, and then 2/3 of them chapter 7 because it's more of a chapter. Mostly just chapter 6 so light for us because I don't expect you guys to do a lot of this stuff in here. Okie dokes. So I'm going to stop here and let you guys spend the remaining time here in class working on these skills. If you want to check anything with me, I'm happy to look at your work and give you some feedback as you're working. Or if you have questions, if you're stuck on something, again, feel free to come on up and ask me, and I'd be happy to take a look at where you're at and give you some feedback, okay?